Good afternoon. Welcome to today's webinar, Important Issues in Stormwater Management and Flooding Litigation. During this afternoon's program, our presenters will cover the following: stormwater problems, damages from flooding, the role and responsibility of an expert, information needed by the expert, Municipal Separate Storm Sewer System, RS4 Program, examples from litigation, the role of groundwater, preventing groundwater problems, groundwater examples, the role of all hazards mitigation, and all hazards tools. The presenters for today's program are Albert Machlin, William Seevers, and Valerie Rifkin. Al Machlin has over 40 years of experience as a professional engineer. He has extensive consulting experience in all aspects of environmental engineering with industry and government. As a former Assistant Regional Director and Regional Engineer for Environmental Quality for Region 1, Long Island, of the New York State Department of Environmental Conservation, DEC, he was involved in major solid waste, hazardous waste, air quality, wastewater, groundwater, and marine issues. Prior to his work with the DEC, Mr. Machlin served as Vice President and Division Engineer for Hydrotechnic Corporation, an international consulting and engineering firm situated in New York City, and provided civil and sanitary engineering services at other New York consulting firms. William Seevers is an environmental hydrologist with over 35 years of experience in domestic and international consulting. He's an expert in the remediation of contaminated ground and surface water and the regulations that govern the water's monitoring and restoration. Valerie Rifkin has coordinated several environmental projects with New York municipalities. She works on multi-hazard mitigation plans, non-point contamination source studies, and oversees environmental grants relating to flood remediation and drainage issues. We'll take a question and answer break after each section of today's program. If you have a question, please use the chat or Q&A feature located on the right-hand side of the screen to submit your questions to the presenters. I've pointed out the location of the chat and Q&A boxes with my red pointer. We encourage all attendees to submit questions throughout the presentation. Tomorrow morning I will send out an email with a link to the archived recording of this webinar. We do ask that you take time to fill out the survey that will appear on your screen after today's program is over. And now I invite you to sit back, relax, and enjoy. I'm going to turn it over to our distinguished presenters, Al Machlin, Bill Seevers, and Valerie Rifkin. Al, the program is now all yours.
Thank you. Thank you for the introduction, Matt. I want to point out that although we are involved in all aspects of environmental engineering and science, for the last few years we've acted as experts for an unusual amount of stormwater and drainage problems which are on the increase, maybe due to climate change. These will all involve litigation by the injured parties, either by residents that have been damaged, for municipalities, for homeowners, or commercial establishments. Well, the first thing I want to go over is the stormwater problems that we've encountered. We've encountered problems where the storm sewers are under-designed and caused flooding into basements and streets. That was one type of problem. And then a common problem that we've encountered is the poor preventative maintenance of stormwater systems. Because of some of the economic problems that some of the municipalities have, they don't do enough preventative maintenance, and sewers get clogged. And we found that is one of the main problems that cause backups in sewers into basements and houses. An incomplete storm sewer network. It's not completely designed. It hasn't been fulfilled. And another important thing is the unusually high amount of rainfalls, both total rainfalls, and the intensity of the rainfalls. We're going to get into that a little more further on. The damages that we're getting from flooding are dangerous road flooding and some of that in the wintertime causes icing in winter and accidents. Basement flooding, which I've mentioned before. Backflow of sewage into homes and public spaces. And that is due to some of the sanitary sewers that collect sewage get the stormwater because of leaking pipes, get into the sewage, it backs up the sanitary sewage, you get a combination of stormwater and sewage going into homes. Undermining foundations, causing structural damage, that's due to groundwater problems, which Bill Seevers is going to cover. And also water quality contamination from off-site discharge of stormwater. And, you know, stormwater is contaminated just by itself. You have a lot of oils, animal waste, decaying organic materials, silt. And when stormwater runs off into surface waters, it contaminates it, and there are laws to cover these things. Okay. The role and responsibility of the expert. Before you pick an expert, you have to really consider the following. The credentials and experience of the expert. The engineer should be licensed in the jurisdiction of every state has professional engineers licenses. The hydrologist should be recognized environmental professional, registered by the association, the Institute of Professional Geologists or the Association of Institute of Hydrologists. Should be recognized as an expert in other stormwater cases. Must have been to the site for observation and measurement. It's very important to visit the site, of course. It's an obvious thing. We have to visit the site, see the layout, the topography, how the water, the stormwater lays out in the street. Take pictures of the area, talk to the residents that have been damaged. And it's very important to get key measurements by a licensed land surveyor, because as you might realize, the topography has a lot to do with it. And if the topography is high here and it's flowing down to a place where it's being flooded, we have to accurately know the elevations of the roads and the area to determine where the water actually flows. Sometimes it's a minor slope, but the water flows in that direction. And should have experience in producing an expert report to be used by litigators, know how to prepare the report. Okay, now we need a lot of information when we do this. The return rate of the storm. Let me tell you a little about that. The National Oceanic Atmospheric Administration has extensive data on rainfalls. They have publications, it's on the internet, so they have over 100 years of rainfalls, daily rainfalls, hourly rainfalls. So let us say you want to design a dam. If the dam fails and 50,000 people are going to be drowned, you look at the worst storm that occurred in that area. You might take the worst storm in 100 years, so it's the highest storm that they've recorded. On the other hand, let us say you're designing a very small development with 6 houses. Now, 6 houses, you don't want to design it for the 100-year storm. It's too expensive. So you look at the 2-year storm, which is 50 times in 100 years. Every 2 years you get that storm. And every once in a while you might get flooded, but if the flooding isn't serious, the development can take it, and economically it's the thing to do. So they design it for a 2-year storm. Now, municipalities often design for 5-year storms. That's 20 times in 100 years. 10-year storms, 10 times in 100 years, and 20-year storms, 5 times in 100 years. 20-year storms is common. The New York State Department of Transportation designs their roads that are special problem roads for 50 years. That's 2 times in 100 years. So that's a higher rate. It's a frequency or return rate, they call it. So that's very important in finding out what the system is designed for. When you have a problem, what we do is find out the frequency or the return rate that the storm sewer system was designed for. And we also check the actual storm that caused the damage. Because if the sewer system was designed for a 20-year storm, and yesterday we had a 100-year storm, it won't be able to handle it, and it'll just flood. Rainfall records, daily and hourly. The reason that's important, take Long Island, you have 44 inches of rain. Now, if, let's say, 100 days of rainfall, so 44 inches, if it's equally distributed over 100 days, it's about 0.44 inches a day. So that's not bad. But let us say that you get a 3-inch rainfall in one day. Now that's pretty high. So that's high, 24 hours. But let us say that the 3-inch rainfall occurs in an hour in the hourly rate. So that's a very high intensity storm, and it's going to just override the sewer system. So we have to have the rainfall records daily and hourly, and that's what we look into. The capacity of storm sewer, we check that, of course. The design of the sewer, which I mentioned, 5-year, 10-year, 20-year, 50-year. The soil characteristics, because we're also dealing with surface water and groundwater, because take Long Island, which has 44, the metropolitan New York City area, it's 44 inches of rain. Half of the rainfall runs off into surface water, and approximately half of it goes down into the ground and gets infiltrated. So when you have a very heavy rainfall, you're going to get more infiltration into the groundwater, and it's going to build up the groundwater level, and you can get basements flooded. And depends on the permeability of the soil, which is the ability of the soil to transfer the water through the soil. So if the soil is very permeable, we know it's going to build up the infiltration is going to build up the groundwater fast. So we have to know that. Topography I mentioned. We have to know the slope of the terrain to see how it slopes down or up. And also coastal flooding, because some of the problems occur near coastal waters where you have tidal problems. So the tide goes up and down 8 feet, let's say, and the storm sewer can't handle it, and that could back up. That tide can back up and cause stormwater backup all the way back. And depth to groundwater and fluctuation range, which is going to be handled by Bill Seevers, the hydrologist, but that is very important, how the groundwater fluctuates and how deep the groundwater is. Okay, the next thing you want to cover is the other information needed. We're not finished yet. As I mentioned, preventative maintenance is one of the common problems. So we go to the municipality or whoever runs that storm sewer. Could be a village, a city, or county, or a state that is responsible for the stormwater system. And when they do preventative maintenance, they do records, field records. They have the name of the person, the day they came, what they did. So we obtain, sometimes on freedom of information we have to do it, or sometimes they just give it to us. We get or through the discovery process, when it's in litigation. We get the preventative maintenance records for the stormwater system to see how well they did it, and I've run across cases where they haven't maintained it properly, and tree roots have come into the sewer through the joints, which are slightly open, and grown in the sewer and clogged the sewer, and then when the water comes back, it just backs up out of it because it can't pass through the roots. So those are the preventative maintenance. One of the preventative maintenance things that you have to worry about. And then we have to look into the federal, state, and local laws governing the stormwater. The laws that require, like residents at a local level, to separate the stormwater, can't go into a sanitary sewer, the way they're supposed to handle the stormwater on their property. So there are laws that apply, and we have to check what the laws say in reference to that situation to investigate the problem further. And then determining the political jurisdiction responsible for the storm. I mentioned sometimes the village is responsible for some of the sewers. The village has sewers, storm sewers, which go into a system that's run by the city or in a county system. And we've run across cases where the village system went into a county system which backed up and flooded areas, and it was due to the county system having not enough preventative maintenance. It was clogged, and it just affected the whole village system. So we have to know that. Then there is this program called the Municipal Separate Stormwater Systems. You notice MS4, M, Separate Stormwater System. That's separate storm. The 4 represents Separate Stormwater System, MS4 program. This is going to be reviewed another slide. But that's a program that requires the handling of stormwater, because in the past, the federal government only took care of containing sewage, wastewater. They didn't really attend to stormwater, but after they treated all the sewage and the wastewater, they found that the water is still contaminated, and they realized that stormwater is contaminated, as I mentioned. Oils, feces, animal feces, decaying vegetation. So there are programs to control the stormwater because the surface waters still haven't reached the standards because of the stormwater. Then there's the Federal Emergency Management Agency, FEMA role in risk management for stormwater. Valerie Rifkin is going to cover that a little later. Meteorological effects. In addition to the daily and hourly data that we collect, we have a meteorologist that looks at the impact of rainfall that occurs like 4 or 5 days in a row. We've run across cases where you have continuous rainfall, which breaks records. You know, you never had that kind of a rainfall at that level. So we have to check the meteorological effect on that situation to see if that was the cause of the problem. And of course, groundwater impact, which I mentioned Bill Seevers is going to handle. So now the RS4 Program. The United States Environmental Protection Agency has a program to protect the nation's water resources from polluted stormwater runoff. This is a contamination control program. It's in New York State, it's carried out by the New York State Department of Environmental Conservation, and they require a permit called the State Pollution Discharge Elimination Permits. They call it the SPDIs for short. One for an urbanized area and one for construction activities. And it's applicable to areas 1 acre or greater. For example, we worked on a project where we were cleaning up a hazardous waste site. Well, during that time, during construction, while we were doing work, we had to prepare a plan to control the stormwater that was emanating from that site, because you get a lot of silt and particles coming off the site which would contaminate the water. So you need a plan to control construction runoff. Then when we were finished, they built these condominiums on the site, and there needed to be a plan to control the normal stormwater from that site that will not contaminate the nearby surface water. So there was construction plan, and there was this is for an urbanized plan, and it needed a permit from the state. And it covers acres, 1 acre or greater, which it covers almost anything. Post-construction, that's the runoff control program. That's the one I was talking about. It's a stormwater pollution prevention plan, and it includes public education and participation aspect. Now, the other thing it covers is illicit discharge detection. Like the municipalities that have to do this program, they have to identify every source of stormwater contamination to a surface water. They have to submit that. That was part one of the program. And then they have to submit a program to eliminate illicit discharges, like discharges from factories that shouldn't be going there, and eliminate the discharges. So they have to identify all the discharges. They've got to develop a plan minimizing contamination using what they call best management practices. One of the best management practices is having a very good sanitation street cleaning project, for example. And then, of course, pollution prevention and good housekeeping, which is part of that street cleaning, and having programs to encourage the citizens to have pollution prevention, not to dump things in the streets. Here are some of the examples that we've come across. They vary all over the place. In the coastal Long Island community, we had a large gap in stormwater system resulting in rising groundwater levels during periods of extreme recharge, to the ground, causing flooding of sanitary sewers and sewage back up into basements. So that was the infiltration going into the ground. Another situation we had, chronic flooding on properties next to a road was found to be due to incorrect crowning of the roadway. That's another. The New York State Department of Transportation has guidelines for designing roads. Now, if you recall, roads are crowned. The sides is slower, and the middle it has a crown. So the rainfall that runs onto that road splits into two, one side to each side. Well, some of the problems we've encountered is where they haven't crowned it properly, where they have the roads are sloping only to one side. And unfortunately, that one side was where all the houses were that were flooded. So the rainfall, instead of half of it going away, all of it was going toward the houses, and that contributed to the flooding of the houses. So crowning of the roadway contributed to the flooding. Didn't meet the New York State Department of Transportation slope requirements from the center line to the curb, so which I mentioned reduced the effective drainage of the road. In a similar case, where the New York State DOT crowning requirements were not met, the road in the wintertime, the road flooding in this kind of a case resulted in icing conditions, which resulted in an automobile accident. So that was a serious flooding is bad enough, but this is a serious accident where people were hurt. Further examples. Okay, failure to recognize the effect on the drainage area by not properly cleaning a recharge basin that received the stormwater resulted in basement flooding in 3 Long Island homes. On Long Island, which you know is a long island, it's about 100 miles long by 25 miles wide. The communities on the North Shore and the South Shore discharge their stormwater into the surface water, the Long Island Sound or the Atlantic Ocean. But in the middle, where you're not near, where you're 12 or 13 miles away from the surface water, the common practice for a very long time has been to dig a hole. It's called a recharge basin, and all the stormwater from that community in the center of the island is discharged to the recharge basin, and it seeps into the ground. So it's very important to clean the recharge basin, otherwise it'll back up, because the recharge basin is taking a lot of stormwater from the whole area. So in one case that we had backup there were about 6 or 7 houses were flooded. They were tied into a county system that was discharging into a recharge basin, and they hadn't cleaned that recharge basin for a long period of time, and all the water backed up right into those houses, the basements of the houses, and the streets. There were a couple of feet of water in the street. So that was one problem we found. Another one, failure to upgrade the stormwater system for a 20-acre subdivision to current standards resulted in flooding. It was designed to contain 6 inches of rainwater in 24 hours instead of 8 inches. The counties have, when developments are constructed, the county of Nassau, in this particular case, has a criteria for the homeowner to capture the rainwater, and formally they would say, you must capture, if there's 6 inches of rainfall in 24 hours, you have to capture it and recharge it into the ground, because most of it is recharged. Well, in this particular case, they changed the standard to 8 inches. I guess 6 inches was not enough. And because it was not, the design wasn't changed and the construction wasn't changed, it was still designed for 6 inches. So when the higher rainfalls came, which are happening all the time, it just backed up into this person's house. Okay, another one is failure of a public school in Long Island to detect a rising groundwater level that inundated the on-site sanitary sewage system, mounded system, which met county health department requirements. This school was, all the sewage from this school went into an on-site sanitary sewage, that's like a septic tank and disposal system. And the groundwater was rising, and of course, if the groundwater rises, the sewage that goes from the septic tank, which is supposed to infiltrate into the ground by perforated pipes, was just inundated, and it backed up into the school. So what the solution in that was a mounded system. We had to mound the earth above the original ground to give it an opportunity for the sewage to be discharged over the groundwater level, which took care of this problem. Okay, now that's the end of this part, and we can have it open to questions if you have any.
Excellent. Yes, thank you, Al. Thank you for your presentation of content. We have some great questions that have come in, and I would encourage everyone in attendance to use the chat or Q&A feature to submit your questions. Al, we have a question here from Joseph who asks, how do you measure the permeability of the soil?
Okay, the way to measure the permeability, and these are standards that each health department has. For example, when you are going to construct you have a house and you want to put a septic tank and a tile field in for infiltration of the ground. The test consists of drilling a hole, like with a post hole digger, and they have certain dimensions, the criteria that they have, and then you put water in the hole, fill it up with water, and you time how long it takes to empty. Based on the speed of the emptying of the water or the drainage of the water into the ground, there are tables that the health department has, and they say if it goes 1 inch per minute or whatever it is, it tells you how many square feet of pipe, for perforated pipe, that you would need. But you measure by actually digging a hole, putting water, and actually measuring the infiltration. That's how you measure the percolation.
Excellent. Thank you so much, Al. We have a question here from Steve who asks, are cities required to upgrade all existing systems if they fail to meet current standards? They should, otherwise they're liable. Because if they leave it on an old design, they're liable to be sued when it floods. Okay, we have another question here from Lyle who asks, if the system is outdated, and this follows up to what Steve had asked previously, if the system is outdated, who bears liability for updating the system? Property owners, local government? Who does the liability stand with? Well, if the municipality changes the standards, unless they grandfather it, if they change the standards, their obligation to tell the people there that there's a new standard and they have to upgrade. Depends on the laws of the, sometimes they have grandfather clauses where you don't ask anybody to do anything, but often they actually ask you to upgrade and fix it. Okay, excellent. We got a question here from Simon. One second. Sorry, go ahead. Right. The other thing that Bill Seevers just reminded me of is that there is an exemption if a municipality, and I think it's in New York State, I'm not sure about the other states, if they have designed it incorrect, if they design a sewer, you can't sue a municipality because they designed it for their lack of design. There's a law that says that. Okay, great. We have a question here from Simon who asks, what types of departments does a typical municipality, i.e. a township, have that monitors or is responsible for ensuring that all drainage systems are unobstructed in order to avoid stormwater runoff damage to property owners? Well, who has oversight at the municipal level of the system? Okay, sorry. Most of them are Department of Public Works. They have responsibility for stormwater, sanitary sewers, and sometimes there are environmental departments, but most of them we've dealt with are public works departments. And the county of Nassau has a public works department. The villages we dealt with have public works departments. Those are the majority. Sometimes it's an environmental department. Sometimes it's a health department. But most of the time, I would say, if you ask me that question, who does it? Public Works. Okay, I don't see any other questions in the queue. So are we turning the presentation over to Bill now, Al?
Yes, we are.
Okay, I'm going to unmute you, Bill, and make you the presenter so you can control the slides. Okay, Bill?
Thank you very much, Matt.
Yep, and let me just give you control of the slides here real fast. Okay, you're now in control of the slides.
Well, thank you. Thank you very much. I'm Bill Seevers. Good afternoon, everybody. I'm going to share some of my knowledge and my experience on the subject of groundwater or underground water. And I'm going to start by saying it's not underground rivers or streams. It's not a mysterious body of water, but it's a predictable and mappable and completely understandable system if you have the right information. Now, the second question is going to be, well, how does this fit into stormwater management, and why are we addressing groundwater when we are actually involved with what seems to be water on the surface of the land, of surface water? And the answer in part is the idea that that groundwater does mingle with surface water, and in mingling and in being part of the same system, it contributes to stormwater issues and problems. Before I go into the details of some of these stories, let me just go through some of the principles very quickly. This is not going to be difficult. Some of the principles that govern the groundwater system. I guess the first question is, what is it and how did it get there? In other words, how did we get groundwater and how did it originate? And it all originates from incident precipitation. And if we took we keep referring to Long Island, but if we took a typical temperate climate, we would have something on the order of 40 some odd inches of rainfall a year. And of that total amount, half of it goes directly back into the atmosphere, either by evaporation or by transpiration, with the plants taking the water back into the atmosphere. And of course, you've all heard the same story to say, well, there's so much water on Earth, and that's not going to change. It doesn't increase or decrease. It just circulates in what we call a hydrologic cycle. Now, what is groundwater? I promised to address that. And what it is this: as the water from the precipitation soaks into the ground, it reaches a point called full saturation. In other words, as the water passes through the earth, it gradually fills the pore spaces to the point where all of the pore spaces are completely filled or saturated. And when saturation is reached, you have what we call a body of water called groundwater. Now, the boundary between that body of water and whatever is above is what we frequently call the water table. And the water table is that surface that marks the boundary between the saturated and unsaturated zones. Now, as we investigate groundwater, we find that it is easily done by simply poking holes in the ground, reaching the water table, and reaching it in a way that allows us to measure the depth of water and the actual elevation of the water surface, which is a very important step in any groundwater investigation. Al talked about having surveyors active in our projects, and that is a very, very, very important matter. In other words, especially for litigation, you can basically create a map of the water table that's very much like a topographic map that you see depicting the surface topography. The same way, the groundwater has a topography. It has high points, low points, it has a slope, and it has changes in slope or changes in gradient. And the hydrologist, groundwater hydrologist or hydrogeologist, will investigate a system by measuring the levels, surveying in the topography, and making determinations like which way does the water move? Is it moving? And of course, all systems are dynamic, so groundwater is always in motion, and it's in motion in the direction of the gradient. Second question is, how fast does it move? And there's no easy answer to that, but in areas of prolific groundwater aquifers, it's not unusual to have a rate of movement of about a foot a day. You could go a little bit more, a little less, but in prolific groundwater systems, we have rates of movement on that order of velocity. Now, on the slide, we've called attention to the fact that the water table varies in elevation from time to time. Over the course of what we call a water year, which are really the 4 seasons of the year, we find that there are periods of time when the groundwater falls as a result of evaporation and transpiration or excessive water use. We find other periods of time when the recharge adds to the system and raises the water table to a higher elevation. These changes are important when we're talking about our subject, stormwater management, because you frequently run into situations where the water table was presumed to be at some lower level, and without any regard to the fact that at other times of the year it rises to the point where it will invade the storm sewers or infiltrate into infiltrate into the sewers and cause extra drainage, which the sewers were not designed to deal with. So we have failures on occasion where the rising water table causes a serious problem. Now, how do you find out and how do you investigate or at least get a general idea of what's going on, and what are some of the things you can do yourself to take on the role of the we'll call it the amateur hydrologist? I'll point out some ideas and you can take it from there. One observation that reveals the condition of the subsurface and the presence of groundwater is something we call base flow. And what that means is that we'll find streams that flow all the time. You say, well, whether it's rainy or whether it's dry, stream flow is active over long periods of time when there's no rainfall. This is a big tip-off to the condition of the subsurface and the presence of groundwater, because the water that feeds the stream during these periods of these prolonged dry spells is coming from the ground, and that flow is what we refer to as base flow. And we have similar issues with underground utilities like storm sewers, where we basically have water that rises to the level of the storm sewer, invades it through the joints and openings, and limits the ability of that system to carry water. So those are some brief ideas on what groundwater is and what it does and how it ties together with what Al has so skillfully presented on his stormwater management side of the presentation. I'm going to say this, that the investigation of groundwater as part of any hydrologic investigation is critically important and is oftentimes not done. And there's many designs that we run into where the designer considered the surface system entirely without any reference at all to the fact that there was groundwater, that the groundwater was predictable, that it could be mapped, its direction of flow could be determined, the rate of flow could be determined, and the actual inflow into the sewer could have been predicted. The same is true of levels. The level of water in some regions is monitored regularly by the U.S. Geological Survey, and the patterns, or hydrographs we call them, of water rising and falling are well known. Final thought has to do with the tools that we have at our disposal for really monitoring or managing groundwater systems, and we call them models. And we all hear about models, computer models and whatever, but groundwater lends itself very nicely to the skills of the modeler and the person that can put together the basic values of permeability and gradient to predict the flow and the direction and the impact of groundwater on stormwater systems. I'm going to ask you to, I've been prompted here, I think the, hang on just a second, is this one? I have one more slide having to do with examples, and I'll say briefly, because we touched on the mounded septic system in the earlier part of the presentation, that here on Long Island in particular, we have areas that instead of being deficient in water or subject to falling water table, or we have rising levels that have to be dealt with by different methods. And one that we did most recently had to do with the design of a septic system that essentially raised the level of ground to a point where we had sufficient distance to separate us from the water table. We also find that some of our studies can be done using published data. We don't have to reinvent the wheel, so to speak. We can use U.S. Geological Survey or county records that publish or keep track of water level changes. And then, of course, I indicated that we would map or determine the topography of the water surface as a routine part of our work. And by doing so, we have determined the direction that water will flow. I think with that, I'll stop and turn it over to Matt again, and look forward to your questions.
Okay, thank you so much, Bill, for your presentation. We have a couple questions here, and actually two that piggyback on each other. Ronald asked, what impact does the active God defense have with respect to water damage claims arising from extreme flood events?
Well, that's a good question. If it relates in any way to the design or deficiencies in the design, it in itself is a weakness in whatever case is being brought. In other words, the public communities are exempt from the claims of failure or deficiency in design. Not speaking, of course, as you would, attorneys would, I would say that we have run into cases where the parties were able to sort out impacts that were excessive and caused by act of God extreme events, and call attention to the fact that the event wouldn't have occurred quite in the same way had the system been properly maintained. And what we generally find is that that argument the clogged sewer or the sewer that's not properly maintained is usually something that is well received.
Okay, excellent. Thank you, Bill. We have a question that's a follow-up question. As you guys know, on the East Coast in 2011, we received a lot of rain due to two hurricanes, Irene and Lee, that caused flooding areas that have never been seen before, and created saturation zones higher than in memory. Is that what you would consider an act of God, and would that limit the liability?
My quick answer to that is no, I don't think so. I think of the act of God events as being the freak storms, or the events that occur very infrequently, and as opposed to trend-type events like hurricanes, which seem to be getting progressively stronger as ocean temperatures increase over the years and things of that sort. So I would distinguish between the event that's, we'll call it the perfect storm event, where things coincide and cause an event of great magnitude, as opposed to the global warming or the ocean temperatures almost predictably increasing to the point where here in the Northeast we can anticipate over the coming years storms of major consequence, just tying that together with ocean temperatures which might hang around 70 degrees going into late October, for example. And when that occurs and coincides with the hurricane season, we get major and large and consequential events.
Okay, excellent. We have a question here from Joseph, who asks, this is with regard to residential basement flooding. What is a French drain and sump pump system designed to manage stormwater going down into the ground, or groundwater rising up, or a combination of both?
Well, it can do both. More often than not, in the systems that we find in our area, it has to do with rising groundwater levels. But not uncommon are the situations where the problem is caused by faulty rain gutters and leaders, allowing water to accumulate around the foundation perimeter, that sort of thing. So I'd say that in answering the question, we have both groundwater levels rising and water intruding into from storm sources, from gutters and so forth.
Okay, excellent. Bill, can you tell us the particular names of models that are typically used by municipalities to track groundwater flow and drainage?
Well, there's a whole bunch of models. They're very specific. I will say it this way, that we have one village, the village of Port Washington in our area, that has modeled their entire system to the point where they could actually decide where to put new wells and how fast and how vigorously to pump them and that sort of thing. Mod flow is a very commonly used model, and that might be one to start with as a.
But it sounds like it's a municipality by municipality decision on what models to use and how to develop those models.
Well, I was going to say that taking a very progressive community like the one I mentioned brought them to the point of actually formulating a village-wide plan for groundwater management by use of model.
Okay, excellent. I think we're going to move on to Valerie. Valerie, just give me 1 second. I'm going to make you the presenter and turn your phone on here just real fast. Valerie, the presentation is now all yours.
Okay, thank you very much, Matt. As Bill touched upon, in recent history, New York, as well as the rest of the world, has been experiencing more severe storms and weather events, as well as extreme temperatures. Scientists have models predicting rapidly increasing sea level rise along with climate change. In this day and age, it is abundantly important for communities to be prepared for the effects of the hazards that this may ensue. Since heavier and more precipitation is expected in the future, and damages from wind and water are expected to increase, it is also abundantly important for these communities to have multi-hazard mitigation plans or all hazard mitigation plans in place. Hazard mitigation is any action that reduces the effect of future disasters. It has been demonstrated time after time that hazard mitigation is most effective when based on an inclusive, comprehensive, long-term plan that is developed before a disaster actually occurs. It is impossible to predict exactly when and where disasters will occur or the extent to which they will impact a community. However, with careful planning and collaboration among public agencies, stakeholders, and citizens, it is possible to minimize losses that can occur from disasters. Federal legislation has historically provided funding for disaster relief, recovery, and some hazard mitigation planning. The Disaster Mitigation Act of 2000, otherwise known as DMA 2000, is the latest legislation to improve this planning process. It amends the Robert T. Stafford Disaster Relief and Emergency Assistance Act by adding a section which places emphasis on mitigation planning. DMA 2000 amended the Stafford Act in two important ways. First, it required states and localities to prepare multi-hazard mitigation plans as a precondition for receipt of hazard mitigation grant program funding and other federal mitigation grants. And second, it established a competitive pre-disaster mitigation program which provides for mitigation planning and project grants before disasters actually strike. DMA 2000 requires local governments to have an approved all-hazard mitigation plan in place to be eligible to receive this funding. The legislation reinforces the importance of mitigation planning and also emphasizes planning for disasters before they occur. Hazard mitigation plans help communities reduce their risk from natural, man-made, and technological hazards by identifying vulnerabilities and developing strategies to lessen and sometimes even eliminate the effects of the hazard. Hazard mitigation planning is a systematic process of learning about the hazards that can affect a municipality, setting clear goals, and identifying and implementing policies, programs, and actions that reduce losses from disasters. Therefore, it leads to judicious selection of risk reduction actions. Okay. There are two important tools that are used when preparing hazard mitigation plans that would be of interest to attorneys. The first tool is used to assist in ranking the potential hazards in a community, and the second tool is used to predict the costs for remediating those hazards dealing with flooding, hurricanes, or earthquakes. The New York State Office of Emergency Management, together with the American Red Cross, developed a program called Hazards New York, or HAZNY, H-A-Z-N-Y. HAZNY is an automated, interactive spreadsheet that asks specific questions on potential hazards in a community and records and evaluates the responses to these questions. It's designed specifically for groups rather than individual use. The HAZNY process involves a logical ordering by priority and perception of the hazards that affect a community. It analyzes and ranks hazards on the basis of 5 factors, which include scope, which covers the areal extent of the impact and the likelihood that the event itself might trigger another hazard or cascade effect, frequency of the event, the impact from the standpoint of the likelihood of injury or death, as well as damage to private property and public facilities, onset, or how much warning time will be received, and duration, or the length of the event of its recovery time. The HAZNY analysis is an effective tool for identifying and prioritizing the risks of hazards that might be experienced in a community. The second tool is called HAZUS. FEMA has developed a geographic information system based on natural hazard loss estimation software called Hazards United States, or HAZUS. The hazardous model is a powerful risk assessment methodology for analyzing potential losses from floods, hurricanes, and earthquakes. In hazardous, current scientific and engineering knowledge is coupled with the latest geographic information systems, or GIS technology, to produce estimates of hazard-related damage before or after a disaster occurs. Potential loss estimates analyzed in hazardous include physical damage to residential and commercial buildings, schools, critical facilities, and infrastructure, economic losses, which include lost jobs, business interruptions, repair and reconstruction costs, and social impacts, including estimates of shelter requirements, displaced households and population, or exposed to scenario floods and hurricanes. The hazardous model is an extremely effective tool which can realistically predict the cost to remediate damages from floods, hurricanes, or earthquakes. And I see that we're running short of time, so I will end here and take any questions.
Okay, thanks, Valerie. I'm actually going to turn all the phones on in your office so that all of the presenters can chime in on questions. We have a question here from Gary who asks, does the fact that a stormwater management system is grandfathered in and exempt from a Stormwater Management Act provide an absolute defense to the owner of that stormwater management system?
Could you repeat the first part of that question?
Sure, I apologize.
Yeah.
Does the fact that a stormwater management system is grandfathered in...
An existing system in place.
That's correct, I'm sorry, yes.
Right, okay.
It's grandfathered in and exempt from Stormwater Management Act. Does that provide an absolute defense to the owner of that stormwater management system?
I don't think so, because there are there's these new laws, the MS4. The MS4 is a federal state law which requires permits, and I don't think that anything is grandfathered on that one. I think they have to, this is for a municipality you're talking about, existing stormwater system?
That's correct. And Al, just for everybody in the audience, can you reiterate what MS4 stands for? Municipal,
wait a minute, let me just go back here. It's municipal, let me just go back here because I remember, I want to make sure all the words are correct. Municipal separate storm sewer systems. Municipal separate storm sewer systems. NAM, municipal, and separate stormwater system is the S4. Municipal separate, yeah.
And to everybody, to all three presenters, are there some resources at a national level that you would recommend to attendees? You know, websites or government agency reports that you think would be helpful in their cases?
Well, I would add to that question the sort of things that we routinely use here in our practice, where we tap into agencies like the U.S. Geological Survey, which is a premier agency and very well with wonderful publications and information on all the subjects that we've discussed here. Going on to the state level, we find that each and every state has an environmental agency. New York State, for example, would have the DEC, Department of Environmental Conservation, and they just publish broadly on all subjects that are of importance to the work we do. Those 2 points of reference can take you a long way, and as you go into more lower level agency or government agency, you find that counties are very active in their collection of information and their publication. So I'd say those are certainly points of information.
Yeah, that's very good. Let me just tell you, give more information. If you go to what Bill said, if you go to the Internet and put MS4 in there, that Municipal Separate Stormwater System, you're going to get a lot of information on that. And if you go to the Internet and you put in Stormwater Pollution Prevention Plan, you'll get a lot of information. This is under the New York State Environmental Conservation. They have a lot of narrative literature explaining these programs. So it's an excellent suggestion that Bill made. But those are the specific things you can check.
Okay, excellent. I think with that, it is the top of the hour, 3 p.m. Eastern Time, so I'll conclude this afternoon's meeting. First, on behalf of everyone here at TASA and all the attendees, thank you to Al, Bill, and Valerie for the time that you put into this presentation. I think we all learned a lot, so thank you very much. And if you'd like to speak, if those in the audience would like to speak to the presenters about a case, you can contact us here at TASA. Our number is 800-523-2319, and we'll put you in touch with Al, Bill, and Valerie to help you with your matter. We'll be sending out a link to the archived recording of this webinar tomorrow morning. We'll also send out a copy of the PowerPoint in that email. All of our webinars are posted in the TASA Knowledge Center. Go to our website, tasanet.com, and click on the Knowledge Center tab at the top of the page, and you'll be taken to the list of our previous webinars. Our next client-focused webinar, Food Products Litigation, Top 5 Consumer Liability Risks the Public Ignores, will take place next Wednesday, February 8th at 2 p.m. Eastern Time. If you have any follow-up questions or comments, we do take everyone's comments under consideration, and they help us to put on better programs. Please feel free to send me an email. My email address is mhyde@tasanet.com. With that being said, I'm going to end today's meeting, and I look forward to seeing everybody at future TASA events. Thank you so much.